since we left out question number 5, we will do question number 5 first, okay? In a classroom, 4 friends are seated at the points A, B, C, D. Champa and Chamili walk into the class after observing for a few minutes. What names? Champa asks Chamili, don't you think ABCD is a square? Chamili disagrees. Using distance formula, find which of them is correct. So they've given us 4 coordinates, right? And then, like, I don't know who puts up coordinates in classrooms, but whatever. The lower one will always be x-axis, and the horizontal will always be x-axis. The vertical will always be y-axis. So for point A, let's write the coordinates first. For point A, we have the coordinate x-axis is the lower horizontal line. So x is 3, y is 4. So x is 3, y is 4. As for B, we've got x is 6, y is 7. As for C, we have x is 9 and y is 4. And then at last D is equal to x is 6 and y is 1. Okay. I guess, yeah. So let's try to find out if it's a square or a rhombus or whatever. It does look like a square. Let's see. So we have to find out AB, BC, CA, right? The distance between AB, BC, CD, and AD. And then we also have to find the distance between AC and BD as well. So first, let's find out AB. We'll be doing shortcuts, okay? So x2 minus x1, so 6 minus 3 is 3. Plus 7 minus 4 is 3. So 3 3 is 9, plus 9 is excuse me, 3 root 2. Let's find BC. 9 minus 6 is 3. 4 minus 7 is minus 3 square, which will give us 9, and 9, which will give us 3 root 2. In case you don't understand from where 3 root 2 is coming from, then it's simply root 18, and root 18 can be written as 3 into 3 into 2. If you prime factorize root 18, you will get 3 into 3 into 2 only. So 3 into 3 into 2, 3 ta 3 do ekta ho jabo, 2 bachi jabo. So 3 root 2. Okay. So we are done with BC. Let's do CD. 6 minus 9 is minus 3. 1 minus 4 is minus 3. So minus 3 square is 9, and 9, which is 3 root 2. Now let's do AD. So 6 minus 3 is 3. 1 minus 4 is minus 3. So we're getting all the sides as equal, which was obvious. So that's a square or rhombus. So let's, for the confirmation, let's find the diagonals, which is BD and AC. Okay. So first let's find AC. AC is these two. So 9 minus 3 is 6. And then 4 minus 4 is 0. So that would be 36 or 6. Next, let's find BD, right? The last diagonal. So BD. As for BD, it's on this one and this one, okay? These two. So 6 minus 6 is 0. 1 minus 7 is minus 6, which is 36 because minus into minus is plus, which is 6. Since all sides are equal and diagonals are also equal, hence it is a square. Yeah, that's it. It's quite easy. So let's do, see, I think it was question number 3. Yeah, question number 3. It's about the question was asking if they are collinear or not. Okay, and then in that particular question it's no. We skip this question also because the answer is no, but I wanted to show you something where the answer is yes. Got it? Because answer no is equal to, you will not get the point of what I'm trying to teach you. That's why I'm made it to like this. So in order to do that, I have to teach you what is collinear, or what do you understand by the term collinear. Collinear literally means when 3 points are lying on the same line. If 3 points are lying on the same line, you can say that these 3 points are collinear. Okay. So suppose if there is 3 points which do not lie on the same line, right, which do not lie on the same line, let's say A, B, C, and let's consider other 3 points which lies on the same line. So suppose AB is 2, BC is 3. Okay, AB is 2, BC is 3. Then if they lie on the same line by automatic, what happens is AC will become 2 plus 3, which is 5, because AB is 2, BC is 3, and since they're lying on a straight line, AC would be 5. That's a very obvious answer. But at the same time, if it's not collinear, we can say that AB plus BC is 5, but AC will not be 5 because AC will obviously be shorter than 5. So like if in case like 3 points are there and you don't, point A, point B and point C are there, there's 3 points and you want to find out if they're lying on the same line or not, all you have to do is see if, because it's not always going to be like like A, B, C, P, Q, R. Sometimes it might be C, A, B also. Who knows what the combination would be. But if they're lying on the same plane, like CA plus AB will be equal to BC. So it's like if there's 3 points A, B, C, then you have to find the distance between these two, AB. Then you have to find the distance between BC, and then you have to find the distance between AC as well, and then see if any of those two is equal to, sum of any of those two is equal to the third one or not. Okay, that's how you know if two things are collinear or not. So in this case, determine if point Q, PQ and R are collinear or not. So our goal is to find PQ, then QR, then we have to find PR as well, and then see if any of those two added up together is the third one or not. Okay, so let's just write the points, I guess. First, P is minus 1.5, in case you don't understand this. 1.5, 3. Q is 6, minus 2. R is minus 3, 4. So first, let's find PQ. For PQ, 6 plus 1.5 is 7.5. Minus 2, I did 6 plus, why? Because 6 minus 1.5, minus a plus, which are 6 plus 1.5, which are, and here also minus 2, minus 3. So minus 2 minus 3 will become minus 5. Minus 5 the whole square, which will be 7.5 into 7.5 is 7, it's 56. So 56 plus 5 square is 25. So if we add this up, we will be getting 11, 5, 6, 7, 8, 81.25, and root 81.25, I don't know. Okay, I'll remove the point first. Okay, if I remove the point first, then we're left with 8125. 5 ones are 5, 3 in hand, 5 6 are 30, 1 in hand, 5 to the 10, 2 in hand, 5 is 25, 5 3 to 15, 1 in hand, 5 to the 10, 2 in hand, 5 is 25, 5 6 are 30, 5 is 25, 5 ones are 5, 5 3 is 15. So that's this 100 becomes 10, will come out from the root, and then 5 into 5 will come out from the root, and then inside the root only the one which is left single will be left. So 25 by 10 is 2.5 root 13. So we're getting PQ. Therefore PQ equal to 25 point root 13. Let's try to find QR. For QR, minus 3 minus 9 is minus 6 is minus 9. 4 minus minus plus, so 4 plus 2 is 6. I hope you're catching along. 9 9s are 81. 6 6 are 36. So we're getting this as 7, 8, 9, 10, 11. 117. 117. I think we can divide it by 3. 3 is a 9. 3 9 is a, so 3 1s are 3 3 to the 3 to the 9. So it's 3 to 13 so from those two trees, 1 tree will come out and 13 will be left. So we have that, and then at last we're gonna find out PR. As for PR, these two, right? These two. So we can do anything. So we'll take, see, it's like minus 3 minus 1.5 growth na, so minus 3 plus 1.5 ho jabo, but since it's minus, it will become minus 1.5. okay. 3, you try subtracting 3 1.5, you get 1.5 only. So that's the answer. Since 3 is larger, it will be in minus, so it's minus 1.5 the whole square. To do shortcuts, your basic in calculations should be spot on, okay? Otherwise could probably calculate mental math also. 15 is 225 plus 1, 325 root. See, and addition time, you always add according to the point. If you're adding plus 1 here, which means 1 should be added here, and you adjust the points. That's why you get 3.25. okay. Let's prime factor 325. 5 6 are 30, 5 5s are 35, 5 1 3. So we're getting 2 5s and 113. But before that, we can make this into this 325 by 100, which will give us 5 into 5 root 13 by, no, just 1 5 na, because 2 5s will become 1 5, so na 5 by 10, that is 0.5 root 13. So we are getting a combination which is, see, since PQ plus PR equal to 2.5 root 13 equals 0 plus 0.5 root 13 is equal to QR, which is 3 root 13. Therefore, they are collinear. See, if I add 2.5 root 13 and 0.5 root 13, it's like we're adding x and x, okay? So root 13 will just come down. So you're going to add only the coefficients. So 5 plus 5 is 0, 1, 3. So it will become 3 root 13 only. Okay, so if you add these two, you'll be getting 3 root 13. So 2.5 root 13 plus 0.5 root 13 is 3 root 13, which is QR, because QR is 3 root 13. So which means this, if we are to plot this somewhere in a graph, the points coordinates will come out, see, Q, R, and in the middle P. It will come out something like this, where PQ plus PR, we get QR. Okay, so that's why we know that it's they're lying on a straight line. So let's start with that. I hope you understood the concept. Let's do another extra question. What kind of triangle does the point this and this form? I think this will be the last extra question from this exercise, but then I will be giving multiple choice questions as soon as we complete the chapter. Okay. What kind of triangle does the point this and this and this form? So let's take the coordinates as A, B, and then C. So it's a triangle, right? So we have A, B, C coordinates. So all we have to do is find the distance of AB, BC, and AC. So let's first AB, find AB. AB equal to root over. This is what we're talking about. Okay, so minus 2 minus 3 is minus 5. Minus 3 minus 2 is minus 5 again, which is 25 plus 25, which is root 50, or root 50 can be written as 5 root 2. You can prime factorize, you'll get 5 root 2. Okay. Next, let's find BC. If we find BC, it would be 2 minus 2. So 2 minus minus will become plus. So 2 plus 2 is 4. 4 square. 3 minus minus 3. So 3 minus minus will become plus. So 3 plus 3 is 6. So 6 square. So we will be getting 4 4 is 16 plus 36 is root 52. Let's see what we get after prime factorization. Root 52. 2 2s are 2 6 are 2 1s are 3. 2 root 13. Okay. Let's find AB is done, BC is done. We have to find AC also. So for AC, so 2 minus 3 is minus 1 square plus 3 minus 2 is 1 square. So we're getting 1 plus 1, which is root 2. See, I can't do anything with this. And if you look over here, here, and here, it's totally different, right? But what you'll notice is, if you look at this one, and this one, not these two, okay, these three, before we broke off the root, you can see that 50 is here, 52 is here, 2 is here. Can you think of any relationship between these three? You see, 50 plus 2 is 52. We're getting something, right? So we took A, B, C, right? A, B, C. So we're getting BC as root 52, AB as root 2, and AC as root 50. So we know it's not an equilateral triangle, it's not an isosceles triangle also, but we can test this out like this. It can be a right angle triangle. Nah? So let's do AB square. I'll just take root 50. Even if you take 5 root 2 and square it, you'll get the same answer, okay? But in this case, I'll just take root 50 because it's easier. Square and root will cut 50. BC square, root 52, the whole square. Square and root cut 52. AC square, root 2 the whole square. You'll know why I'm doing the square right now. So this squared is this squared is this squared is this, but we're getting a relationship from this, that is AB square plus AC square. We're getting 50 plus 2 equal to 52 is equal to BC square. AB square plus AC square equal to BC square. And this, for a triangle, this satisfies what? Pythagoras theorem. And Pythagoras theorem is applicable only in what kind of triangle? In right angle triangle, which satisfies Pythagoras theorem. Therefore, triangle ABC is right angled triangle where so which angle do you think will be 90 degree if it's a right angle triangle? We're getting BC square, right? So BC it's like, you know that since BC is here all along, it means it has to be the hypotenuse. So even when you're drawing, you have to know that 90 degrees here, so this should be BC, the hypotenuse, because it's the longest side. So if BC is here, then A is here, which means the 90 degree which would be which angle, where angle A equal to 90 degree. So like, you know, these kind of questions might not come, like exactly this question might not come, but they can manipulate these kind of questions and ask you what is the measurement of angle A. So this is how you would know what the measurement of angle A would be. Or sometimes it might be an equilateral triangle, they'll ask what measurement is angle A. You'll have to write 60 because equilateral triangles have 60 degrees, all the angles. Okay, before we end the class or session, this session, I want to do something. I'll explain the formula for our next exercise so that as soon as we start the next exercise, we can directly go fast. Okay, so section formula. What do you understand by the section formula is that the x coordinate is given by this. I'll tell you what m1 and m2 is also, don't worry. Y coordinate is given by this. Okay, so the x coordinate is given by this, y coordinate is given by this. Now what is n1 and m2? So if there's a straight line, there's 2 points, let's say x1 by 1 and then x2 y2. Two coordinates are there. The point coordinate is this, the point coordinate is this. Suppose this on this line there lies another point, I don't know where, let's say just another point. It is A, this B. There lies a point C, such that this point C divides this line into two ratios, m1 is to m2. Then the point C coordinate will be given by x, y. Let me explain that properly again. Like the ratio part, okay? Like suppose there's a line which is 10 centimeters long. Let's say line is 10 centimeters long. So like if there's a point on any part of the line such that the point is in the, if I divide the line into 5 equal parts, then the point is lying on the second part of the 5 equal parts. So if this is a line and this is divided into 5 equal parts, which is 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. So that's 10 centimeter, right? So from here to here is 2, 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 and then from here to here is also 2, let's say. And then the point is lying here, right here. So the point will divide the line into 1, 2, 3. 3 is to 2 part, which means 3 parts are here, 2 parts are here. You can literally take 2, 2, 2, this is 6, and then 2 and 2, that is 4. And then cut it, 2 3 0, 2 2 0, which is 3 is to 2. So the ratio with which the point is dividing the line is 3 is to 2. So we can use this, or we can do this for anywhere on the point. Like we can literally divide, if like there's a line and I put a random point here, I can make this point as one of the fractions of whatever is being divided. This one is dividing the line into 1 is to 2 part, because 1 part is here, 2 parts are here. Okay, so m1 m2 is just the ratio at which a line is being divided by a point. And kuntu point पर divide करिएज ना, the point with which the line is being divided, the point kuntu point पर divide करिएज उतु point का coordinate बिचारो गर्ने इतो formula use करें. So let me repeat that. Whatever point is dividing the line in m is to n ratio, that point ka coordinate, the coordinate of that point, we can find it out by using this formula. So that's called section formula. You can write down the formula and keep it. So this is only this part, okay? The formula you need to write down, this or this. Sometimes I'll be using this because this in one go we can find the coordinates, so it'll take lesser time. but sometimes I'll have to use this when it becomes a little complicated to do everything in one go. Okay, so according to the situation, we'll use both the formulas, but it's the same thing. On the x coordinate is given by this, y coordinate is given by this. So same thing. Oh, and one more thing. If suppose a line is there and let's say x1 y1 and x2 y2, 2 points are there, and then those 2 points are being joined by a line, and in the middle of the line, middle, like exactly middle, midpoint, okay, we have another point xy. So the ratio will always be divided into 1:1 part, because there's a one part here and one equal part over there. So whenever this happens, whenever there's whenever we're trying to find a midpoint of a line, okay, so this is a line and we're trying to find a midpoint. Midpoint means dividing the line into two equal parts, right? So whenever we're trying to find a midpoint, you're going to use the ratio as 1:1. Nah? So shortcut formula would be x equal to, since m1 and m2 will be 1 and 1 only, we'll be getting x1 plus x2 by 1 plus 1 is 2. I just wrote x1 and x2 directly instead of x2 and x1 because it's easier to remember this way, and since it's addition, 2 plus 3 and 3 plus 3 is same thing only. So, and y will be given by y1 plus y2 by this. So if there's a midpoint, we can literally use this formula as a shortcut also, just to save time. Okay, so that's the formula, and this is a formula for midpoint. Okay, that's it.